Hello and welcome back. Now let's understand more on the memory map, especially the stack and heap area of JVM. Fine. And also in the process, we will understand about instance variable, local variable, reference variable, what is the difference between them. About the static variable separately we will try to understand. In the process we'll understand about the JVM architect. So static keyword separately we'll try to understand. Static block, static method, static variable, that will be discussed separately. For now, instance variable, local variable, reference variable, also the memory maps, which is heap and stack area. Before you get into this video, I hope you have watched the video which we have talked about class object creation, also the concept of methods. I'll keep in mind that those who are watching these videos, they know about class object creation and methods concept in Java, or also in general about variable. Fine. Now guys, I'll create one variable here. I want to store the information, someone's age I want to store. I'll say age and I will store as 16. Great. It is of integer. I will write this as integer. Now this variable you can call as instance variable also. You can call this as instance variable. Also you can call this as local variable. This can be instance or local based on where have you written for the first time. That means where have you declared your variable for the first time decides whether it is a instance variable or it is a local variable. Syntax wise you will not see much changes. Of course, apart from this there are other differences also we will understand. To start with, the very first difference, where have you written or where have you declared that variable for the first time decides or differentiates between instance and local variable. Other differences also we will understand. Coming to the reference variable, suppose we have a class here, class alpha, any class name in that matter. Some code is written here. I'll be creating the instance object of the particular class, object instance, object creation, instantiation, all of them are same. If you have to create the object of this, I'll say here new keyword. As you all know, if you have watched the previous video, we say new. Again I will say here alpha, new alpha. Object is ready. To this object I will give the name, maybe whatever name you want you can give. I'll give it as A. It is of what type? Alpha type. Alpha type. Now this A is a reference variable. That means such a variable which is referring to an object. It holds the address of this object. What do you mean by that? Also in this video with respect to memory map you will understand. Fine. So let's write a basic program by keeping in mind the fundamentals and try to understand memory map alongside these differences between these three variables. Fine. So I have written one class here, class addition. I'll create some variables to store the number, integer type of number 1 comma number 2. Since both the variables has same data type, like this you can directly create, no problem. In the Java basics we have seen that. Now I want to add two numbers. That means there is some activity here for which you have to write a method. I'll be writing the method here add. I'll accept two numbers here, integer type of number 1, integer type of number 2. Great. And then I will just do one thing here. Inside the num1 variable which I have already created, please add whatever is there inside the n1. That means whatever I am going to receive here, I am going to add it. Please do watch how to write methods, previous video which is there in the same playlist. How to write different method, different ways, the methods in Java in detail I have covered there, all the 4 possible ways. I have kept in mind that you have already watched that video. Fine. So after which I'll say here num2 equals to n2. Great. I will say here integer type of result, integer type of result equals to number 1 plus number 2. Fine. After which I'll say maybe return the result. I'm returning the result here. That result return type is result, res of what type? It is of integer type. I will say here integer type is the return type. Method is ready. Now I have to create the object of this. I'll say here new addition is the class name. So object I'm going to create here addition. Great. And I'm going to give a name to it. Whatever name you want you can give. I'll give the name as add or maybe A. Anything is fine. Okay. and the reference type is of addition because A is holding address of addition object. That means it is referring to an object. It is not holding any integer or string value. This is holding addition type of object. It is referring to addition object. That's the meaning of it. I will say A dot add. I'll pass some integer values 4 and maybe one more integer value I would like to pass here 44. Great. And then whatever this method will add and give back, it is returning you back integer value, right? I will go and store inside a variable called as integer type of R. Whatever variable name you want, you can give. Intentionally, I'm not giving this variable name. You can give same also. I don't want you to feel that whatever you are returning here, at the time of collecting the data, you have to give the same variable. That mindset should not come. So only I'm giving a different variable name. You can give any variable name. It should not be a matter of concern. System.out.println. I will say here result is, and maybe I'll say here R, whatever data we have inside this variable. How to write methods? Again, there is a detailed video available from the scratch and covering everything about methods we have seen. Right now, memory maps about the methods in this video only we will understand. Okay. If I have to run this program, if I have to execute this program, you can see the result is 48. Of course, 4 plus 44 is 48. We are getting the desired result. Very simple program here. Now, please look at here. Number 1, number 2 is of what type? Integer type. For the first time, where have you declared? Directly within a class, directly inside the class. We call that as instance variable. Why the name instance? I will tell you when I talk about the memory in the same video. For the first time, where have you declared? Directly inside the class. Now we have, I'm using it. That's not a matter of concern. You can use it. Alongside the data type for the first time, where have you declared? That's what you have to make a decision again. Fine. Now you can see here res. It is also a variable alongside the data type. For the first time, where have you defined? Inside this method. That means this variable is local to this method. It is a local variable. It is a local variable. In fact, the parameter variables also local variable because for the first time you have given inside the method only. So such variable directly inside the class, if you have declared instance variable, if you have declared inside a loop, inside a block, inside a method for the first time, maybe I have declared here, I'm using it here. It is again instance variable only. Alongside the data type for the first time, where have you defined? Where have you declared? That's where it differentiates between local and instance. Very first difference. Other differences we will understand. Coming to this R variable, result variable. For the first time, where have you declared? For the first time inside this method, right? So it is local to main method. It is local variable to the main method. Syntax wise, very first difference between instance, local and reference variable. I hope you could able to differentiate. More we have to understand. Also the memory map. So I would like to take this program here and go back to my board work, and I would like to demonstrate the same program here. Let me just add this program here. I would like to add it. Let me just get back here. I will reduce the size and let it be there. Great. So let's understand the memories and what exactly happens here. Two important runtime data areas is what I have told in the last video. One happens to be stack area, runtime stack area. One more happens to be the heap area. This is my stack area and this is my heap area. These two areas are part of JVM runtime data areas. Internally, at the time of Java code execution, JVM uses these areas. Fine. Last video we have discussed. Now, JVM will start the execution from the main method. So control would come to the main method. Main method, it is also a method. That means within this some activity is written. In order to execute, whenever control goes to any method to execute that activity, what happens is on your stack area, one stack frame of that method gets created before executing it. That means control comes to the main method. To execute the body of main method, it will be brought into the runtime stack area. One stack frame, also call it as activation record. Anything you can give, activation record or the stack frame of main method. main method. So entire main method code, of course in the form of bytecode only, main method code will be present here. Fine. Now the execution of that will start. Very first line, you're creating the object. Equal to means always right side. So object, what have we understood in the last video? For object, memory is allocated on the heap area, right? On the memory is allocated on the heap area. So memory will be allocated on the heap area. Very first line, you are creating the object. So on your heap area, memory will be allocated. And every object will have an address. This object for which memory is getting created, there will be some address. I'll assume the address is 1000. It could be anything. This is just an example. So right side, the object creation, during that object creation itself, it will check inside that class, are there any instance variable? Instance variable means such a variable which are declared directly within a class. Directly inside the class, we have two variables. Inside this object, the memory for those variables will be allocated. Number 1, number 2. Okay. And one more important point. For these variables, default value also JVM will allocate. Default value means right now at the time of declaring these two variables, did I give any value? No value. Then JVM will initialize default value. Default means based on the type of data. If it is string, then the default value is null. If it is double, it is 0.0. Right? Similarly, it is an integer, the default value is 0. Now, default value for all the instance variable is not 0. No, based on the type of data. If I create instance variable of double type, then the default value will be 0.0. If you create string type instance variable, then the default value will be null. Fine. Now, during the object creation itself, more in the constructor you will understand. For now, ignore the constructor part. Separately, I will discuss. During the object creation, on your heap area, one object will be created, address will be given. Inside this object only, for this class, whichever class you are creating the object, if there are any instance variable, memory also will be allocated. Also, JVM will initialize default values based on the type of data we have there. Default values have been initialized. Right side part is over. Then left hand side part, right side is over. Now whatever object is there, that object address will be stored in a reference variable called as A. For A, memory is there on the stack area inside the main method, because you are creating this reference variable inside the main method itself. It is local reference variable. Fine. So inside this we have 1000. In other words, A is such a variable which is having the address of this object. In other words, A is referring to this object. That is the meaning of it. Fine. So this part is clear. Next line, again equal to operator is there. It is going further with the execution. Equal to operator is there. Right side to left side. First right side part. We are taking the address of this A. A has the address of this object only, right? A dot means go inside this and call this method called as add. Call this method called as add. Also, you are passing 4 and 44. 4 will come and sit here. 44 will come and sit here. Now, in order to execute the body of this method on your runtime stack area, one stack frame will be created. Stack frame of add method. So whenever there is a method or a block or a loop, in order to execute the body of that, on your stack area, one stack frame of that particular block or a method will be created. Right now, I am calling the add method. That means control is going to the add method. To execute the body of add method, one stack frame of that add method is created on the runtime stack area. Also variables for the parameter variables, which is also local only. Memory for N1 also created. The data which you're adding is 4. 4 is what I'm passing here, right? So 4 will come and sit here. N2, again 44 will come and sit, because 44 is what you are passing here. It will create. And now whatever data is there inside the N1, you are assigning to num1. Num1 is instance variable, memory already created inside the heap area, inside the object of heap area. So I'll say here 44. Yeah. Again N2 number 2, which is 44. Fine. After which you are creating one variable res alongside the data type. For the first time, where are you creating? Inside this method. That means this res is local, not directly inside the class, right? So memory for res will be inside the stack frame of add method, res. So memory will be allocated number 1 plus number 2. You are adding and giving 4 plus 44, so 48 will come and sit here. After which you are returning this. That means you are asking control go back with the 44 value, 48 value, because the result inside the result 4 plus 44 is 48 is there. Alongside this body, control will go back here and you're storing inside the R for the first time along with the data type you're creating inside the main method. So inside the main stack, memory for R will be allocated, which is 48. So anytime you can rewatch the video also, anytime if you're getting the ambiguity. Very calmly and very detail I'm trying to explain here, and this is very, very easy also. You have to listen with complete focus. Anytime you can rewatch in 1.5x speed also, any ambiguity if you have. Fine. So you can see here 44 is assigned. After which, since the control is moving out of the add method, right? That means the body of add method execution is over. So behind the scene, the stack frame of that method also gets deleted. So it will get created when you call the method to execute the body of this. The moment the body execution is over, when control leaves that method, the stack frame also will be deleted. All the memories also will be deleted. Again, I'm printing it. So on your screen, of course, you'll get the message result is R. No more message, control go back to JVM. So what happens here? Since nothing is there, no more body of a main method execution is also over. So stack frame of main method is also deleted because execution, everything is over now. Whatever code was there, all of them got executed. So no more lines are there. The stack frame of main method is also deleted. Now, if the stack frame of main method is also deleted at the end, so reference variables was there inside the stack frame of main method. If main stack frame is only deleted, reference variable will be there? No, reference variable is also gone. Now, on your heap area, there is an object for which right now no one is referring. In Java, there is a concept called as garbage collector. So automatically, for which you need not do anything. Automatically, there is one garbage collector which will keep on scanning the heap area and check, is there any object for which no one is referring? That means, is there any referenceless object? Such an object for which no one is referring. Now, reference variable of this object was there inside the main method stack frame. Once the body of main method stack frame is over, the entire code of main method got executed, the stack frame of main method also got deleted. In that case, what happened? The reference variable which was there inside your stack frame, that is also gone. So this is also gone, right? So entire stack frame only gone. So whatever data is there inside the stack frame, will that be there? No, of course not. So that is also gone. That means this object which is there on your heap area became referenceless. That means no one is referring to this object. And whenever there is a referenceless object on the heap area, garbage collector will automatically collect this object. So this object also will be demolished. It will be deallocated and your program will be executed. I hope you could able to understand here. The point is, memory for local variable will be there on the stack area because they are declared for the first time directly inside a method. So that method stack frame which gets created on the stack area, memory will be allocated there. For instance variable, memory will be on the heap area inside the object. For object, we also call it as instance. Object means instance means both of them are same. So it is why we call instance variable for this, because this is getting allocated inside the object, right? That means inside the instance on the heap area. Directly if you declare a variable, we also call that as instance variable, because memory for such variables which are declared directly will be allocated inside the instance, inside the object on your heap area. So now coming to instance variable, memory is on the heap area. Great. If we don't give any value, JVM will allocate the default values based on the type of data. That also we have understood. Great. The third point about the instance variable is it gets deallocated the moment garbage collector collects this object. When the object becomes referenceless, right, garbage collector will deallocate the memory. So garbage collector will deallocate the memory. when object becomes reference-less. And this instance variable you can access anywhere in the entire program. What do you mean by that? For the first time I have declared, right, I can access here also. If you want, you can write one more method. For an instance, I will write void display. One method I am writing here, okay? Inside this method, again, I will say system.out.println number1. Nothing. I'm just printing. Forget about printing and doing whatever. Maybe I'll assign some other value here. Number1 equals to 44. Okay. I will say system.out.println number1. Now, see here, am I giving any data type here? No. That means for the first time, if you declare that variable, I can access anywhere in the class. Inside this method also, I'm able to access. Inside this class also, I'm able to access. But for the local variable, for the first point about the local variable is they are declared directly inside the method alongside the type of data. This res, this r. Inside the method directly we have declared. Second point, default value will not be allocated for it. Default value will not be allocated. That means if you create a variable like this, maybe I'll create here integer type of a variable, and I will not use any default value. I would like to try to print here. I'm getting one error here, compile time error. The local variable may not have been initialized. That means there is no data inside this. Why are you using it? That means if you create a local variable alongside the data type inside a method, then you may have to give the value. If you don't give value, default values will not be given. If you declare the instance variable, I have not given any value, right? The JVM will give the default value at the beginning of the video, which we have discussed, which is based on the type of data. If it is integer, 0. If it is double, 0.0. If it is string, it is null. Making sense? And third point is local variable memory will be allocated inside the stack area. When you call this method, to execute the body of this method, stack frame gets created on your stack area is what I have told. Inside the stack frame only memory for this will be allocated. Hence, local variable memory will be allocated on the stack area. When the memory will be deallocated for the local variable, when control leaves the method. That means once entire body got executed, control leaves, right? That means no more things are pending in this method to be executed. So entire stack frame will be deleted. In that case, memory for local variable is also deallocated. And one more point, local variable, they are local to this method only. See here, res alongside the data type, I have defined inside this add method. It is local to there. If I try to use in some other class, I'll say here maybe 4, some other method. See, I'm getting an error. What is res? See, res cannot be resolved. What type of data it is? Java is an strongly typed programming language. You have to specify the type of data. Where is the type of data? Please give. If you give one more time, then it is not the same res. This is a different res. This is a different variable. Fine. So now if you don't specify, that means I cannot reuse it. So local variable are local to the method. Outside the scope of method, you cannot use. The scope is limited to this method only. Outside this method, you cannot use. Instance variable throughout the class, everywhere you can use. Coming to reference variable, reference means such a variable which will not be holding any int or float or double or some string value. It is referring to an object. Such a variable which holds the address of an object, which will refer to the object which you have seen on the memory map also. I hope you could able to understand what is instance variable, local variable, reference variable, and what happens on the memory area also, stack and heap area. Going forward also in our upcoming videos, again we are going to explore this heap and stack area for many examples, for many coding. Any ambiguity you have, you can rewatch the video for n number of times. 2 times, 4 times, 5 times. If with complete focus, if you are watching this with complete focus, I'm pretty sure you will be in a position to understand everything. If you have watched with the focus, if you have understood, please do like the video, subscribe the channel, share with your peers and colleagues, and please do support me. Thank you so much for joining me in this video. Again, we'll meet in the upcoming videos and understand more on Java.